Hi, I'm Per. Welcome to Lund, where we are making dynamic conductive charging a reality.
Imagine if electric vehicles never had to pause to plug in, but could rather recharge as they drive. This is the mission of Elonroad, a scale-up looking to transform e-mobility and ease the grid strain associated with EV expansion. A solution that started off as a collection of Lego blocks has evolved into a potential game-changer across sectors. We visited Sweden to find out why ports in particular are taking notice.
Thank you for welcoming Enlit on the road to Elonroad. Electrification is booming.
Yeah.
Tell me, what is the problem or the challenge that you're trying to solve?
The problem is that with electrification, we're going to need an enormous amount of batteries that all need to be charged at the same time. We're going to need a lot of space for all these chargers, and we're going to need a lot of power, concentrated in small spaces. We are solving the problem of power levels, peak power demand. We're solving the problem of space. We're solving the problem of cost of vehicles. We're actually reducing the cost of vehicles with this charging methodology. The whole company came about because our founder, Don, was an early adopter of electric cars, and he was driving between Malmö and Lund in wintertime, and his battery was so weak he couldn't turn on the heat. He was freezing to death. So then he looked at a string of snow between the wheels, and then he thought, maybe there could be something there that I could charge from. We went home, started building a prototype, presented it to the university here, and eventually we got funding. It's a conductive electric road systems. We're not the only ones who are thinking about this. There are different approaches to how to do it. Conductive means in contact. You actually have metal to metal. The electrons travel from one piece of metal to another piece of metal into the battery management systems and charge the vehicle as they move. Then you also have the inductive charging, which is our competitors. That's where magnetic fields make electrons move, which makes the transfer of energy quite tricky. But the conductive, you can actually go very high in a simpler way. The challenge here is to make it safe. What's unique about it is that we are working in a segmented technology. The way it works is that you have communication going on between the vehicle and the rail itself, because you only want to turn on the power under the vehicle. So the vehicle sends a signal telling the road where it is. Then we have a computer, a controller card, which communicates with power cards that activate the power to the plus segments. So you see every second one here is a plus segment. So this would turn on plus, minus, plus, minus, plus. Now you have sliding contacts, and you have enough of them so that you're always in touch with both plus and minus at the same time. You need at least 3. Usually we go higher to keep the current level down in each brush. You can do this really fast with modern switch technology, and you can go very, very high. So we can actually power up 350 kilowatts in 120 kilometers per hour, theoretically up to 160.
Per, help me understand, where would this be implemented?
Well, I think the whole development of all of this stuff, all these technologies happen with the aim of public roads and heavy transport on public roads. But then it turns out that you can actually use this type of technology in many places, not just public roads. So what's happening right now is, where is the electrification going fast? It's going fast in some closed loop areas, particularly ports, where the problems are acute right now. As ports go electric, they have problems with space, they have problems with the cost of vehicles, they have problems with how much peak power that is accessible in their grid. This technology can solve all of these problems. For example, we are building in Long Beach this year, where we will build 400 meters of electric road, and then we will also add like 5 very short stretches of electric road, which called static charging or opportunity charging. So where these cranes or these tractor vehicles can charge while they're waiting to do something else or while they are loading something else. And then you'll have the actual electric road, which will be under the ship-to-shore crane. So as the vehicles move back and forth, carrying containers, pulling stuff around, they will be charging as they work, which means that you can keep everything running 24/7.
This technology won't remain in ports, though. Surely we will see deployment in a variety of sectors.
Well, that's the end game, obviously. I mean, ideally, we would like to see this type of technology on public roads everywhere. And you don't have to have them on all roads everywhere, but you have to have them on enough roads. But the problems that come with electrification, they are visible in closed loops. They're visible in logistics centers. They will become painfully visible in the rest of society as the numbers of electric vehicles rise. So for us to start with the ports, we can actually tune everything and make it work before we go more on public roads, even though we actually do have some public roads projects as well. If all goes well, then we will build 2 kilometers of electric roads, ERS, on the A10, which is a highway just outside of Paris.
Per, this solution has started off in a rather small area here in Sweden, but it has really big global potential.
Yeah, absolutely. I mean, this whole started actually with the Swedish Transport Administration and the collaboration with the Swedish and German, where they started looking at electric road systems as a way of electrifying trucks long distance. We're seeing an incredible interest in this solution from all over the world.
Tell us more about some of the partnerships you formed.
I mean, we work, for example, with Aishin, which is a Japanese company, part of the Toyota group. But we also work with port vehicle manufacturers like Kalmar, Terberg. We have a project with Scania. We have a project with Renault. We have one with Volvo. I mean, the OEMs, the big manufacturers, were slow in the beginning, but something has been shifting very clearly the last year. They start to think, okay, we actually have to rethink. They've been used to thinking that they could just, copy filling up with gas, but they're starting to realize, we can't just build mega chargers everywhere because the grids will not be able to handle it. We have to rethink.
If I have an ordinary electric vehicle, how easy or difficult would it be to utilize this technology?
Well, right now with the static chargers, the short rails that you use for charging while you're loading or unloading or waiting for something else, it's mega simple. It's CE marked, it follows the CCS protocol. You can fundamentally just put one of those under the vehicle, then you have an adapter to your normal plug, you're good to go. But if you want to charge dynamically while driving, we need to work with the manufacturer of the vehicle because it will not allow charge as it is moving.
It sounds good, but
Yeah.
I would assume that there are costs involved. When it comes to implementing innovation,
Yeah.
there's some risk. How are you mitigating these risks and managing costs in terms of the deployment of your system?
I think when you talk about the electric road systems, they are a major infrastructure investment that can only be done by government or by a major, international road operators. Big risk involved because it's millions of euros. It costs about 100,000 per kilometer to install. That's why we are focusing also on a short version of the road where the cost is actually on par with traditional chargers where you can't drive, you can't move, but you stand still, but you charge automatically as you're doing something else, like in a loading bay or while you're waiting to pick up a container, for example, with a forklift. And then you have to look at the whole total cost of ownership. What are you going to spend? Either if you electrify, you're going to have to maybe increase the power to your whatever location you have. You have to have some kind of charging infrastructure, and you have to buy vehicles with big batteries. So if you can charge while you're moving, you can reduce the size of the battery significantly, which means the vehicles will become much cheaper.
Europe has some very ambitious electrification and decarbonization goals.
Yeah.
They're ambitious, but are they realistic?
We're trying to change a system that's very, very established, oil and gas, has been running the world, and it's got about 100, 150 years of perfecting that system, and now we're trying to do something totally different. It's a new way of thinking around energy. The old way of doing things is just filling up the tank. Now we carry around a tank, which is exceptionally expensive. It weighs the same whether it's full or empty, so why not reduce the size of that tank and pick up the energy as you're doing something else. Electricity is very different from diesel and petrol, so we have to do a lot of rethinking about where do we charge, how do we charge, how fast, what power levels, who charges at what time, etc., etc. It's going to demand an enormous amount of collaboration and innovation.
Are grid operators able to meet that challenge?
I don't think so, no. Sweden don't have a energy problem, we have a power problem. right now. Our problem is that when everyone needs electricity at the same time, the grid can't cope with it.
Well, it's been absolutely fascinating. Thank you so much for sharing your insights. For more insights, join the Enlit community.